Welcome again. My name's Tony. I work at Avid Exchange. I don't work on C++ right now, but I have plenty of times in the past. This talk is not specifically about C++. This talk is about agentic coding. And a talk about agentic coding ought to be named Context is Everything, because that's really the only thing that there is to talk about when it comes to AI, give or take. Context is everything for AI agents. It's probably everything for you too, you just don't realize it. Thank you, Nascent.
I got my picture, we're good.
Thank you, Sovereign.
I'll edit that out.
Okay. This is not a hold your questions until the end talk. Please ask questions. If you don't ask questions, we're going to go to the pub way earlier. That is fine, but just so you know. And I typically do the same thing every time I give a talk. I've noticed after doing this one. So the structure of this is like half slides, half code along exercise. I am not just going to sit up here and lecture at you. We're actually going to get into doing some agentic coding. We're going to do some of it together. Yeah, that brings me real well to my next slide, which is that there's a lot of ways to use AI. And there's more going on right now. Since I started doing this talk in January, started preparing for it, things have changed a lot even just in those 2 months. So you can use it to learn a subject. You can use it to explore options. I like to use it as a strategic thinking partner. It's great at creating diagrams and documentation. It is also, as it turns out, pretty good at reading and writing code. And that is what we're going to talk about today. None of these other ones, just the read and write code part. So the goal of this talk is to give you a passing level of understanding of how to use agentic coding tools. I want you to understand where we're at today. I don't know that you will understand where we are at a month from now just by listening to this at the rate that things are going. But I hope that everyone leaves this talk able to speak intelligently about it, at least where we're at today. The goal of this talk is not to convince you that AI is good and that you should use it, or to convince you to like AI, or to convince you that it's okay to use AI, or to convince you that you're going to be worse off if you don't use AI. And it is not to convince you to come and beat the AI dead horse, so to speak. It is just to give you a passing level of understanding of where we're at. I am perfectly fine if at the end of this talk, all you get is a better vocabulary to tell people why you don't want to use AI. Okay, so let's talk about what context is. Context is the set of available information to a model at inference time that influences its next output. It includes conversation history, system prompts, tool definitions, environment state, memory summaries, prior plans, and retrieved documents. There's probably even more that I'm not thinking about in here, but these are the big ones. Some of these might be surprising. I think something that I encounter a lot is people don't understand the difference in behavior when they ask the exact same question to the same model when they're using two different tools. And the reason is because those tools are doing things behind the scenes. They're injecting context into the prompt before it goes out to the LLM. So these things will find their way into your workflow, and you have to kind of think about what your tool is actually doing. So in order to talk intelligently about these things, we kind of need a shared set of vocabulary. And we're slowly getting to the point where this is like pretty industry standard, but it definitely was not when I started putting this together. So if other people have other terminology for these things when you're talking to them, you'll have to kind of suss that out. But here is the terminology that I'm going to use. So an agent harness is the software infrastructure that wraps around a large language model or AI agent, handling everything except the model itself. It is your front end. It is Claude Code. It is anti-gravity. It is open code. It is your curl when you're making the curl request yourself. That is the thing that's on your computer. An AI agent is an orchestrated system where an LLM acts as the reasoning core inside of a loop that interprets goals, chooses actions, executes them via tools, observes results, and iterates until the task is complete. So an agent harness is basically running an AI agent and using a model to do so. Does that make sense to everybody? Okay, great. An agentic workflow is a workflow where an AI model performs tasks through iterative planning, tool use, reflection, and multi-agent collaboration. So we've just added the 3 levels, right? So an AI harness uses an AI agent to run an agentic workflow. That makes sense to everybody? Does that feel pretty clear? Great. Please speak up if at any point you have questions, comments, whatever. Again, I'm expecting people, I'm expecting this to be a conversation. What's up?
Can you give an example? You gave an example of one of those. Can you give an example of each of those?
Okay, so when I open Claude Code, I have my harness, right? When I ask Claude Code a question, that iteration of me asking it going out to the LLM and coming back with an answer, that's me using an AI agent.
Is the agent running on the server or on your machine?
So an agent has 2 components, right? The server is the core reasoning component, and what's running on your machine is the actual machinery. So it's both. And if I tell it to go edit a piece of code, which invokes lots of calls to an AI agent, where it reads the code, which is really your harness basically calling out to the LLM and saying, here's what he's asked you to do, and gives it a set of things that it can do. And the LLM calls back and says, I want you to give me the contents of that file. This is what happens whenever you see in your harness, reading file, right? And then it sends back, and it goes back and forth until eventually it actually materializes code. That is an agentic workflow. Does that feel pretty clear?
Mostly. I'd love to see what Jason said, where are each of these pieces exactly?
Yeah. We'd need to work at Anthropic to go look at one of them, but all the others we'll kind of talk about. You can do this yourself. The piece of code that Alec and I are working on right now, basically we built something very similar to this, where we're doing all of these things ourselves. And we'll talk about how that works, but there's all the machinery is either in the black box of a harness that you downloaded from Anthropic or Google or whoever, or you can actually kind of write one yourself. We'll get into the machinery of how all that works. Okay, so the anatomy of an API call. So this is what it looks like when you call an API, right? There's really nothing here of interest except for content here, right? This is all just typical curl headers and HTTP traffic stuff, but this is the context.
So have you sniffed this? Do you know this is an Anthropic? I mean, I'm just curious if this is what Claude would send. This is what Claude sends to Anthropic.
This is what I sent to Anthropic.
That's what you sent. Okay.
With that Claude code is going to do this, the content's going to have a bunch of extra content.
It's also
Yes.
Anthropic's
Context, okay.
documentation for
Yeah.
their API.
Yeah.
Well, I was just curious about the next token specifically.
We'll
Yeah,
talk
yeah.
more. We'll talk more about what a call to Anthropic inside of your harness looks like in 2 slides.
Okay, very
But the point that I'm trying to make here is that the only thing the LLM knows about is the context, right? The text that you've sent it. That's all it has to go on. That's its entire premise as a reasoning machine. So let's look at the anatomy of a reply. So this is what you sent, and this is what you get back, right? So it's been a minute since I looked at this. We asked it, what is 2 plus 2? And here's 2 plus 2 equals 4, right?
Everything's going dim.
Yeah, that messed with me. The rest of this, again, is just, everything else in the response is not something that we as humans really care a ton about. You might care about it if you're trying to write a harness yourself.
So
But
I'm going to keep asking questions, though.
what?
So you're saying, when I send that curl response,
You don't send
the
it.
context is not at all kept on their Anthropic side. We have to send the full context every time?
That's a hard question. About 3 months ago, I would have told you, like, I don't think so. If they do, they don't tell me. Now there's features available where Claude has a thing that will let you click to like read previous chats.
Right,
So they obviously have them, but there is no inherent machinery in place to do something with it unless
So at least conceptually, we're sending the entire context window every single API call.
you absolutely are.
All right.
It's at least inferring on it. You might be able to do it incrementally, but
Yeah.
the inference is running on.
Okay.
Yeah.
And there are like specific, I suppose, like different kinds of protocols that you can do and that make it so that you keep a lot more of your context in your VRM and don't have to like offload it every time.
Right.
At least like if you're running the model yourself, that is very important.
Okay.
And there's no memory.
What?
There's no memory.
Yeah, and that's just like more context that's being stored on the server side that it gets injected when you make an API call to it, right? Anyway, the point that I'm trying to make here is that it is all text. There is no black magic here until you get to the actual LLM, which then we start to say to ourselves, okay, this thing is maybe black magic. But like the interactions with one, it's just text in and text out. So let's look at what happens when you call a tool. So here, what's happening is I'm sending a message, and it says, what is the weather in San Francisco? But we also give it this section here, which is letting the LLM know that there's a tool available to it. And this tool requires an input of a location, and it will give you back, so here's the input schema, and where does it actually describe the output? Okay, current weather.
Is it just text? Doesn't it just have to always be?
Yeah, I think it just has to infer it in this case.
Yeah, you can have like modeled outputs.
Yeah,
You can provide a JSON schema of like this is what I want.
yeah, absolutely. These tool calls can take a couple of different.
Question. So what or who decided to that, in order to answer that question, that tool is needed?
The get weather tool.
Okay, let me explain it this way. I am asking Claude, what is the weather in San Francisco? And I am also telling it, by the way, on my machine, I wrote a function to get the weather wherever you ask for. And if you tell me that what you want to do, where is it at here? That what you want to do is call a tool, then I'll call that function for you.
So that's a tool on your machine.
It's a tool on my machine.
Oh, yeah.
And in fact, you can write it. All of the like things that harnesses are doing that people, I said I told myself I wouldn't do that.
Oh, you'll say it again.
Jason's gonna meticulously edit out all of that.
No, I'm not.
A lot of the really sophisticated interactions that happen with your harness and your LLM are tool calls. But the tool calls are inside of the harness. Somebody, okay, let's say you've got Claude Code. Somebody who works on Claude Code wrote these tools. And now whenever you call out to the model, Claude Code tells it, you've got these tools available to you. You can do this yourself. In fact, this is a thing that the product that Alec and I work on right now does a lot, is tell it, we've got a lot of tools available to you. Do you want to use one of them for the task that we're asking you to think about? But the point that I'm really trying to make here is that there's not like a lot of structure here for a tool call. It's just text. It's structured text in the sense that we put it into a curl very specifically, but the LLM basically just reads it as text and infers, okay, I have some tools available to me. I've comprehended that by reading the text here.
Very good at reading and writing JSON.
Yeah. Does this make sense to everybody? What's up?
Question. So you have tools on your machine that you are telling it exist.
Yeah.
Are you describing exactly like, oh, there are these parameters, this is how you use it, this is input, this is output, or are you just describing in natural language? Like
You can do both, but you'll get better results if you're very specific. So for
Just to check, I think from earlier, every time you send, you're sending it all of the tools every time.
well,
'Cause
it
there's
depends
nothing
on
your machine which is interpreting your query and saying, oh, I need to use get weather tool. So are you just sending it your whole list of tools every time?
that depends on who is making the API call. If you, Ben, go into curl and make this, you decide, right? If you are asking for, I keep saying Claude code, I feel like I'm going to get sued. If you're using anti-gravity, then anti-gravity is deciding what tools it's sending along with this and telling the LLM it has access to.
So it might not send all the tools all the time.
In fact, it does not, depending on the settings and things you have.
There's an inference model running on your machine which is doing that.
It's
How's
not a
it
model.
deciding which tools relate to your query? That's my question.
Yes. So
Or is it sending a query to the LLM?
no, it does not do that. So we're getting ahead of ourselves a little bit, but it's great. In your agentic coding tool, when you click planning mode, what it does is, amongst other things, it injects some prompt, some context that says, we're planning, the user wants a plan. And it also mutates the tool permissions that are available to it to like non-mutation. Don't write code, but you can read code kind of thing. And it will also curate that list. You know, maybe there's something that's like make a file, and that's not part of making a plan, so it will not give it that tool. Does that make sense?
It makes sense. I just want to know, like, is that code classified as AI? Or
No.
Is that
No, that's
just
you,
some algorithm that someone at Anthropic wrote?
yes, absolutely. And you can write one yourself. Like, it is not actually that hard. I mean, it takes a lot of, like, it is a big program to write. AI can write it for you.
And a lot of them actually do just put the whole list of tools at the top, and you can
Yeah.
tell because it'll be like, asks a question, and it's like, I have all of these tools that I can use in the thinking response, and it's like, no, I didn't ask you about the tools, actually.
Yeah, we're getting into the heart of what makes a harness effective at doing this, right? And why they're getting better at a pretty fantastic rate. It's because the number of tools are going up and the management of these tools is getting better. But no, it is not an AI model that decides what tools to send back. It is your harness. And I do not know of any workflow where the AI says back to the harness, you got any more tools for me, man?
But it could.
I suppose it could, yes. Yeah, exactly right, yes.
If you were to dynamically load tools, it would actually be via a tool for dynamically loading tools.
That's what it would have to be, yes. You would have to give it a tool that's like list tools. Okay,
What is stop sequence?
I have no idea.
It's a token, a special token.
No,
Yeah.
I mean, it's some blue text, right?
Yeah.
It says null. Really?
Yeah.
That's just my editor. I literally threw these into my editor and then screenshotted them so that they look nice. Okay, great. This slide's almost redundant at this point. So I think we know what a tool is, just for iteration, right? It's just structured context that defines some available action in the environment on the client side.
Okay.
What's up?
So you've got lots of, I suppose, messages, user role. Do you use any not instruct tuned models, any base models for like code generation, interpolation kind of stuff, or is it all instruct tuned? Like I suppose trained specifically to do the user assistant.
I don't understand the question.
I suppose like the fundamental models that are just kind of like predicting the next token versus like if you tune them specifically.
Are you talking about the LLM doing things like thinking? Which side of the equation are we on? Are we on the client computer or are we on Anthropic's server?
Well, so I mean, I suppose it doesn't matter necessarily. It's just the underlying model. If it's tuned, fine-tuned, trained to respond in the user assistant just doing like next token prediction, because the raw models will do the next token prediction.
Yeah, OpenAI has, I don't know if it's like a paper, just like a blog post, because you can't tell with them, but like, they have it where they take this JSON and then they tokenize into something that's like, it's just straight tokens, it's just text, and it's kind of doing this, but not in this way. So it like, even if it is like tuned for this, it's like, it's not actually reading, they're not actually giving that, the JSON itself. It's like, I don't even know what you call that. It's like compacted in a way, but it still says like user and assistant, but like in a less straightforward way for a human reader.
Sure, yeah, and I mean the user assistant stuff is like really common now, and like the raw model usage is much less common. I was just curious if there was any like usage of that in these kind of.
Oh, are you asking me if like the harnesses have them? That's not open source. Well, some of them are, but I haven't read open code, but I have no idea. I haven't.
System prompts?
I think so.
No, just like
Are you talking
the
about
underlying.
like a codex model? Like GPT 5.3 versus GPT 5.3 codex?
Like
Because it's all just
Llama
post-training
3
differences.
raw versus instruct tuned.
It's all just post-training differences.
Yeah, it's like the raw model is just predicting the next token.
But you changed, like, you fundamentally changed the weights in the model,
Yeah.
but like in the post-training.
Could you do tool use with something that is not trained to be a helpful assistant and is just predicting the next token?
Yeah,
Yes.
They had that, and they had to develop a thing called like guardrails, which would try to like take the output and shove it back into JSON. With like in it, it had to be a lot fuzzier than I guess what we have now.
Before tools existed, I actually asked it to get me JSON, and I actually used it to do things. It can. Sometimes.
Everybody feel pretty confident about what a tool is? It's just a function on your machine. They can choose to use it. Executing it is then the job of your machine. Okay, so what is an MCP server? It's a collection of tools, resources, and prompts. Tools meaning executable functions. Resources meaning contextual data objects that the model can read, or just more text. And prompts, reusable templates for structured interactions, or more text. What's an agentic skill? Model context protocol. No, I didn't. What did he say?
MCP is the master control program. Someone had to know that they were doing that.
My favorite one is the S in MCP server is for security. Okay, now we're starting to get into more recent developments. Okay, so what is an agentic skill? Just out of curiosity, has anybody in here heard of an agentic skill but does not know what it is?
I'm in that category.
Okay, great. That was me until I started doing this talk, actually. So a package containing a reusable agentic workflow for AI agents, containing instructions, relevant context, scripts, and or assets for conducting a repeatable agentic workflow. We know what these words are now, right? Does this definition make sense? It's instructions for running an agentic workflow.
More text.
It is all more text. You can actually have all kinds of text now. You can have PDFs even, but it is at the end of the day. You could also have a picture, which the AI is going to tokenize into text.
It says repeatable agentic workflow, but since the models are stochastic, your output is still.
That is correct. Just because the workflow is repeatable does not mean that the output has become deterministic here, okay?
You're still rolling the dice.
Yes, but I think that you will find that from a literal standpoint, it's not going to be true. From a,
Weighted dice? Yeah.
exactly, yeah.
This is a slightly off topic, but I'm curious if that API gives you any way of specifying the current seed value so you actually can get repeatable output.
You can provide the seed.
Yeah.
You can provide it in your request.
And you can also dial the sampling algorithm
Okay. Does this make sense to everybody? This is like big sticking point. A good example for a skill is something like compiling code. Okay, so I wrote, I think we'll actually get to this tonight. What's the time? Okay, I've got the time right here. You can write an agentic workflow that does something along the lines of compile this code and fix any errors that you see during compilation, right? That's a repeatable workflow. Now, is it going to do the same thing every time? Definitely not. But it is a thing that you will do often if you're, trying to offload your work to an AI instead of doing it yourself. And that's like a repeatable thing that you can put into a packaged, little container. You might even put a make file in there that's like, this is how I'm compiling the code. You're going to run this make file. So you'd have like a .md file that says, this skill is all about compiling the code. You're going to do that with this make file, and the make file is in the same directory, and it will know where it is. I think I saw Brian first. What's up?
So, skill is kind of like influencing the harness. Like, can you like add like tools into a skill?
Yes, you can. We're going to use one later, but like anything that you can do when you're typing into your harness and trying to give it a thing to do, right? Which includes giving it tools, giving it scripts, giving it MCP servers. And an MCP server is almost entirely just exposing tools for the most part these days. It can do other things, but I don't see people do it in practice.
Is that the right way to kind of think about it, where like a skill is kind of like steering your harness in a way that's more repeatable?
Conditional, poor man's conditional.
YAML top lock that describes when to use the skill, and so you can have that ability, but you don't have all of the text of how to do that until you're trying to do that thing. So, like, can the agent choose to use a skill? Okay.
Yeah.
To use a skill that invokes a tool that loads the skill, which just waits the time.
I think this is the right time to talk about the like why I'm up here on this soapbox about context. And that's because in the current state of the art, the amount of context that a model is thinking about determines its accuracy, for better or for more or less. The way that I like to think about this is, do you guys remember getting math problems where there was a piece of irrelevant information and you had to not think about that? That's basically what we do to our models when we give it a lot of information. Like you ask it to do one task and then you ask it to do another task. It's still thinking about that first thing that it did, and it has to reason harder in order to realize that that's not important. And it trips over itself like this. So all of these things that we are talking about here are really context management techniques. The point of an agentic skill is to move that context into a different place so that you're not using it until you need to, which is going to increase the accuracy of the task that you're actually asking it to do. This is why I like the CMake example. I don't want it to go off of the rails thinking about my CMake system until it's time to compile the code. I want it to think hard about the actual piece of logic that we're trying to implement. We'll worry about compiling the code later. And ideally, we'll get into this too, we would just do that in a completely separate set of context because the problem has been solved. I don't need to think about that anymore. I need to think about compiling code and fixing the errors. This gets tricky because sometimes fixing the errors means that you need to know about what we did to the code. And so that's where an agent really comes in handy. But there's another tool. Did I get, nope, okay. We already talked about AI agents. Okay. So what about all these fancy AI harness modes? How do these relate to these things that we've learned? If this is really all there is in the state of the art at the moment, then what happens when I do something like ask or agent or plan? It's just curating the set of context that we're sending to the model. Ask mode sets tool permissions to non-mutating, and it adjusts the prompt saying the user wants an explanation to their input. Agent mode adjusts tool permissions to full edit, and it adjusts the prompts to sort of, for lack of a better word, prompt the AI to give it output, to actually carry out actions, use tools, explore things, get results. And plan mode sets tool permissions to non-mutating and adjusts the prompt to break down the user's request into actions in a sequence of tasks that can be carried out. This is all it does. It's more system level prompting, more tool permissions. It all gets bundled up into a nice curl request, or maybe some other, as I'm learning tonight, some other means of talking to the LLM, but it's going to be HTTP kind of traffic of some kind. What's up?
Have you heard about Cursor's debug mode? And I haven't used it, but is there any difference between, say, using ASC mode and throwing it error output from your compiler and using debug mode? Or error output for your one?
It's probably using tools that give it access to shell sessions where it can actually call more tools like attach a debugger, make a breakpoint. I mean, all the things that you would do in your own shell, it's probably getting access to those tools and using them with the LLM as the reasoning core on what action to take next. I haven't looked into it, but if I were going to try and implement that feature in Cursor, that's the way I'd do it. So I'm guessing that's what it does. I'll go read about it and let you know if I'm horrendously wrong. But I don't even see a way that it can do more than that, right? Like what Cursor must communicate with the LLM via text somehow. There's no other protocol that's available to us. And Cursor doesn't, well, I guess it does have its own models, doesn't it? Geez. But for the most part, it's not the owner of these models it's communicating with. So it has to adhere to publicly available specs that you communicate with them through, which we can then go look up and know exactly what you can do. Okay. I think I've hammered my point home that there's really no black magic once you make your curl requests. It is all text at some point that it is you trying to explain to the LLM what you're trying to do. So at this point, right. At this point, I'd like to do some of these together. I'm going to kick off this run, and then I'm going to talk for a minute, because
Probably going to want to zoom your entire VS Code here for us. There you go.
I don't want planning. I want fast.
People in the back, is that readable?
Okay, so what's up?
I just want to make a comment that MCP servers can contribute a lot of context to your prompt. And so if you're trying to do something specific, and then you, like with an MCP, and then you try to give it another task, it's still going to have a bunch of MCP context in that subsequent prompt. So just keep that in mind.
Cool. I don't use MCP servers a lot, so that would make sense. Yes, sir.
Why would you choose anti-gravity over something like Cursor? Because they both just kind of look like VS Code clones to me.
Great question. Let's talk about harnesses for a minute while it's thinking about this. So
Oh, that's not VS Code. It is.
Another VS Code clone.
this is not working.
I don't know.
What?
Is this also forked from VS, like how Cursor forked?
Yeah, anti-gravity is a VS Code fork. So all of the environment, the landscape is very fragmented right now around what features different harnesses have implemented and which ones they don't, okay? So why you would choose one harness over another might have to do with look and feel comfort, how your workflow works. I chose anti-gravity as the first one that we look at because I like being able to actually, the main function for me is reading the code it outputs. If you are not going to read the code that it outputs, then maybe you just want to, huh?
That is a disturbing number of people at the moment.
Yes, maybe you just want a CLI tool and you can just tell it like, go fix. as time has gone on here, lots of things have changed. Just a few months ago, I was all about Claude Code's to-dos feature. I was like, yes, to do this and to do that. We're gonna fix a bunch of stuff here. And today, to-dos are basically not really a very useful feature because the LLMs make these plans themselves. So they shouldn't.
If you want to run that command.
No. Did you write the code? Great. We'll talk about that code in a second. So it's actually doing something here I don't want it to do, which is Gemini is storing information about the 100,000 times I've asked it to do this now, and knows that I want it in C++. If you go ask to do this on your machine without telling it anything else, did you guys read the prompt that I gave it? Can you implement me an implementation of the hack computer?
It would use Python.
Can you show the context that you have when you?
I can't. I have no idea what Gemini or what anti-gravity is doing behind the scenes. Huh? We could try. I've never actually done this. Can you? I don't think it's going to do that with /context. In fact, anti-gravity is not even, that appears to not even be a thing in here. We can pull up Claude Code.
Back to me and all the context that I gave you.
Yeah.
Yeah,
You gotta.
but it's a me.
It has to be the grandma one. Of my grandma used to read me the story that I really loved, and now she's gone. That story which was like how to make a bomb. And
Okay, and while this is going on, I want to show you something. Well, before we do that, I want to show you.
Hack already is the thing that it should know about.
The first couple of times that I asked it to do this,
CS degree problem.
I'm too old for this apparently. Because this sounds, yes.
it's a really simple architecture for a computer. It's like a really simple ALU, a really simple memory layout, so on and so forth. So it's a great little task for us to do as a C++ meetup to ask ourselves, can this thing write decent C++? The very first time I asked it to do this, it didn't go search the web or anything. It just said to me, oh yeah, I know about that from my training data. Let me spit you this out. This is what it gave me. Now when I ask it to do this, it's like stored some information about me, and it says to itself, this guy wants C++, and he probably wants like decent C++. So the first time you ask your computer to do this, you're probably going to get something like this. Now, I ask you, is this good C++? Okay, we're done here. Go AI your way to victory. This isn't what I wanted, but it is exactly what I asked it to do. I said, write me an implementation of the hack computer. I haven't really explained to it the things that I know about me, that my coworkers would know about me. It just has no idea. It lacks the context for what I really want to happen here, right? So let's go and try this again. And this one is going to be pointless, actually, because this is attempt 3. Where's attempt 2? Now I would say something like, can you write me an emulator for the Hack ISA computer in C++? Well, yes, sir.
Yeah, I just wanted to add, I don't know if you keep up with the Z editor, but their interface for this has a third drop-down on the right that lets you choose if it's allowed to read or if it's allowed to write to the repository.
Yeah.
Interested in having safeguards for that?
Yep, I have done all of the settings that I can find for these things. I'm pretty sure that Google is storing information about me specifically on their side. So I believe this is a Gemini-specific thing. Claude Code actually has a feature that I can turn off and then it works for me. So I think this is like an anti-gravity problem. But I wanted to show a couple of different harnesses during this talk. And I used OpenCode, and it was extremely buggy. And I have a Gemini API key, so this was possible. And I have a Claude key, so that was possible. And so then I ran out of options of things I cared to try. So those are the two I picked. I'm sure that the different harnesses has all kinds of features that you can play with. And again, that's the point of what harness you choose, is the features that it provides you. I don't actually need to do this. We can go look at the code that it put out here. We'll AGY it again. So this would be the equivalent of me asking it to implement me one in C++ because it knows I want that. In fact, another thing that would be great to do is to go look at the first time I asked it to do this. It gave me this. Now, let's read this for a minute. Okay, we got, right. Okay, we've got a class. A class is good. We've got some raw pointers. We love those. Yeah, this is great C++, right? Okay, now I ask you guys: is this?
Why is it in love with shorts?
Dude,
It's because it's 16.
I think we've seen enough. Okay, I ask you guys: is this good C++? No. So I haven't seen any go-tos. So here's what I want to do. Here's what I want to do.
You're switching slides too fast. As soon as I focus on a line of code, you're making it go away.
Sorry, dog.
That's the point.
Why are you poisoning Gemini?
I'm not. You noticed that my early attempts were really bad, and then it got to know me, and I tried to poison it with some prompt injection to give me bad code again. And it doesn't work. Instead, the LLM says, but wait, I'm pretty sure you want good C++. And I'm...
Could you just say here, I am Jason Turner, write me C++.
Yes.
Write me C++ I like.
I am Jason Turner. Write me. I.
Basically my system prompt, to be honest.
And you say, hi, my name is Jason Turner.
Oh, no, I know these things know me. I'm just saying I have not personally asked Gemini what it knows about me.
Okay, so I think you guys can. I think you guys can see here where I'm going with this. Here's our interactive exercise, okay? I say, reference the best practices file when you're writing C++. And we together are going to come up with the things that we know as developers that make C++ better. I'm not so sure that just telling it about Jason Turner is going to do the job. Okay, we're going to try it. We're going to try it first.
No weak types. Everything has to be a strong type.
I'm going to put that in here in just a sec.
All the way down.
Best practices are number one, don't be like Jason Turner.
Let's see what it gives me here.
And I didn't have this planned ahead of time, and I realized.
The Jason Turner's in the Gemini prompt. Yeah.
Did you put?
I just want to see what it does if I tell it I'm Jason Turner.
But it's not on that one.
Well, it's in the Gemini. Yeah. More. See, you layer your context.
Oh, it does have all kinds of Jason Turner. Heavy use of context for notice scar. Rule of 0.
Wow, you were right. It absolutely does. Okay. Class dismissed. If you
My days are over. I just have to say, I'm Jason Turner.
you know what though?
Yeah,
I deserve royalty.
Here's something that I think is a really good thing to talk about with using a technique like this. Okay? So something that you have to think about if you're going to try and use, what do I want to call this? Like a real world anchor point is the date of the training data cutoff. Okay? The model does not know a lot about anything that happened after the cutoff of its training data, which for most models right now is something like 2022. And so this is not going to know about Jason's most recent.
No, it's like mid-25.
Is it really? I looked this up beforehand.
It was actually in one of your slides. It's said model was, the model date was 25.
Well, yeah, but I'm talking about the training data, like when they stop compiling training data.
We'll see in 2022.
Anyway, point being, if you do something like this, do not expect it to know about the video that Jason put out last week, right? It's only going to know about the things that it was trained on. It can go search for them. A lot of times it will not unless you tell it to. And then another thing is that,
You should have said you were Ben Dean, not Jason.
you have a lot more searchable information, I think. Oh, now I lost my train of thought. Oh, so there is a lot of human reinforced learning that happens post-training, and they do perform backpropagation based on the things that they learn from user prompting. So this is not a hard and fast rule. They know nothing about anything that happened after their training data, and they will have to go search and read for it. That's not necessarily true, but it is something that you'll need to think about in general. Is it asking me questions? Didn't I tell you to?
So what do you want to write to the CPP best practices?
Okay, I'm done trying to get it. We saw that it would look up some Jason Turner things. I want to actually do this exercise. Okay, so somebody said something about no weak types, right?
Yeah, there better not be an int anywhere in the entire field.
I would recommend that you use positives instead of negatives to say use strong types.
Yes.
Yeah.
Agreed.
Only strong types.
Yeah.
The only thing I say negative in it is like no emojis. If there's emoji in here, I'm closing the window.
It does feel like if you say negatives, then it likes to use the negatives.
Correct.
Then it's contacting them.
What else do we know as C++ developers that it needs to know? Right. This is what's very annoying about this. Context for all the things.
Const eval as much as possible. Ooh, I've never asked it to do that before.
Use CDs.
Yes, indeed, as well. Const eval as much as possible.
You can, but well, that's attempt 4.
No unconstrained templates. Everything needs a concept.
All right. I thought this would be more of a hit, but
Are we having fun?
We're all afraid.
I
We're all afraid. It's like asking us our opinions on Git. You know?
What did you want us to say?
this isn't actually what happens if I ask it. Okay, we can run this experiment here. I want you, in the spirit of Jason Turner and Ben Dean, to write me a C++ best practices file with all the techniques for writing good C++ later than C++ 20. I can't hear you. What's that?
Can you ask it to consider adding some rules from the core guidelines?
It's like the one thing that C++
Yeah.
does that nobody else does.
Because these rules exist.
Yeah, they do. It will often search for them when I ask it to do an exercise like this. Yeah, that's fine. While that's thinking, I'll show you where I go with this next. So I went through this exercise, right? I put together a file.
Nobody knows what a monad is, Ben.
Did you ever ask an AI? Yes.
I mean, I think it's a monoid in the category of that.
Oh, that's right. I forgot about that.
So I sat and talked to an AI about the things that I know that I do when I'm writing C++. And I put together this file. It's got tons of stuff in here. It's fairly long. We could read the whole thing, but it's pretty standard. Const correctness. Prefer the stack over the heap. No raw pointers. If you have to use a pointer, it should be a shared pointer or a unique pointer. Prefer a unique pointer over a shared pointer. Where? Yep. And so what happens if I ask the LLM, this was the prompt that I gave it, right? It's the exact same prompt before we added it to say things like Jason Turner in the last attempt. The exact same thing. I get a very reasonable outcome here, right? We can go read some of this, and
Why are we squiggling on the standard library things? It just doesn't know about them.
what are you talking about?
I'm wondering why there's squiggles under the string.
Because they're unused.
They're unused.
Well, the red one.
No,
is
it's
fine.
It's probably just like the.
it's just my
They are included from the previous.
it's just yeah, it's just my editor.
JSON is missing.
Okay, sorry I asked.
Yeah, I do not have linting all set up for this.
That could be.
Anyway, we can sit here and look at this, but I think that the C++ that's here is pretty decent. It's reasonable. Things that it did not do that I wanted it to do was const expr things. It did not perform to like the maximum of my hopes and dreams. I did not sit and talk to it and tell it, you didn't const expr this. Please go do that. This was just my first shot, because the point that I'm trying to make is you will get better performance by just telling it what you want. And the way that we're using agentic tools on my team and the way that I'm getting decent performance out of them is I am just slowly compiling a set of skills, context, so on and so forth, of the way that I want code to be written and the things that I know about the code that I'm looking for that just haven't been written down for it. And so that's kind of the point of making this best practices file and then writing this code, even though it's not perfect. I can imagine with time, if we sat and we iterated on this exercise, as you probably do iterate on things at work, and you write down more of the things that you know about the language, you'll get better results from these things as you go. What's that? This was with Flash, yeah, and low. But it's a really small exercise. I mean, okay, yes, I can throw Opus 4.6 high at it, and I probably get something great. But I think that's, that's expected for such a like well-documented, well-defined small task, in my opinion. I guess I'm trying to artificially simulate complexity here by using a model that's not so smart. And maybe that's not apples to apples comparison, but oh yeah, with tests and everything. The CMake is fine, but let's talk about this, because now I want to talk about taking it to the next level.
Here's a question. Yeah, just real quick. Do you have like a mental guideline of like when you would use agentic code and when you wouldn't? Because it all seems fine. So when it's fine, not good enough.
I absolutely do not know the answer to that question. That is a question for you. That's a soul-searching question for you. There are people here who are going to tell you, you should never do this because you're going to ship bugs to production. That's probably not wrong. Also, I'm going to ship bugs to production, right? So somebody else will tell you, well, the AI ships less bugs than I do. There's no right answer here. I usually think about this in a red, yellow, green model where there's code that I just don't care if it works or not, and that's green. And I will just say, hey, I want to see a chart of like all my Git commits for the last 30 days and how many lines of code I wrote. I do not care if that has bugs in it, okay? Yellow is these things need to be right, but it's okay if the AI does one part of it. If I write the code and it writes the tests, that's okay. I'm pretty confident I wrote the code, and I'm pretty sure that its tests are right. Maybe in the yellow zone you also still read the tests. I think of it this way, but I know some people think of it as the AI writes the tests, I write the code, or vice versa. The AI writes the code, I write the tests, I wrote the tests, I know that they're right. And then there's the red zone in my mind where I say a bug here might send someone money that's going to come out of my company's pocket, and I I'm just not comfortable with the AI having some sort of very subtle bug here. And so I'm going to write the code and I'm going to write the tests. This is the way I think about it. This is very personal and everyone is going to feel differently. If we go get Steve Yegi, or whatever his name is, the guy who made Gastown, he's going to be like, you don't need to read any of that. It's good enough. Just let the AI, have at it. Because that's kind of the philosophy that Gastown presents itself, is there is no reading of the code. You just describe the product to it like a product manager, and it AI agents its way to victory.
You'll also develop a feel for this, right? Like if you start doing this tomorrow and do it consistently for a year.
I ask it in like a pointed way, because I have used these and like I've gone away from using these because like the productivity gains are zero if you're working on like a enterprise code base. Because like you end up just with all reds, and you're like, yeah. Anytime I lean towards yellow, you get bit, and like I don't know what a green would be.
I mean, so if you're asking me specifically, I would tell you you are probably not providing it enough context about what you're doing. Because I do think that you should be seeing some value. I mean, at the end of the day, look, I don't buy into the like the AGI hype, okay? I think that this is basically fancy code complete. All that these models are doing is predicting a series of tokens. It just so happens that code is a series of tokens, and that it's aptly positioned to do well at these kinds of tasks, okay?
I will say too, like, it's improved a lot in the last, like, couple months. Like, if the last time you tried this stuff was 6-8 months ago, give it another shot.
We're recording, so I won't say much.
No. A, I think it's fine, and B, your opinions are valid here. Every person has a different experience with this, and if you're not getting good results out of it, only you know. Again, my only goal here is to equip you with enough knowledge to know whether you're getting good results out of it or bad results out of it because it's just too hard of a problem space for it, or if there's things that techniques other people are using that's allowing them to get good results that you haven't tried yet. That's my only goal here. Yes, sir.
Yeah, I'm just wondering, since you've obviously done a ton of this, I think the way I hope that these tools can go is that there's a body of, whether it's official tools or skills or whatever it is, that makes it better and better and more accurate and more accurate and more accurate. But I wonder, based on your experience, do you find that at some point the AI just hallucinates beyond reasonableness, and so no matter how many guardrails you have around it, it's just like we've reached the end of the usefulness to continue to get this to be more accurate? Do you feel like you've kind of reached that space where you're kind of playing with that lever, or do you think we're just going to keep getting better and better?
I'm not sure. I wonder if I've maybe failed to make my point around how context management is the key to success here, because if you are noticing a lot of hallucinations, it's probably because your context window is filled up with a lot of things that are not helpful for it. I mean, I generally consider when my context window gets to 50% that the IQ of my AI agent has gone way, way too far below what I would accept as quality results.
Your experience is that it's getting better and better over time as these context-specific tools and whatnot get better. Your results are better. Like you're finding that's a linear graph essentially.
I think it does. It performs differently on different kinds of problems. For example, if you're writing firmware, I'm writing web code. It's really good at writing web code. It's not great at writing firmware. So there's different problem domains here.
Is that because web code is more pattern?
No, it is because of human reinforced learning. When these models are done training, the providers actually spend time teaching them how to code, and they spend more time on certain things than others. That's why it has language proficiency. That's why it's good at Java. Well, that's why Claude is good at Java and not as good at C++. Although I'm trying to demonstrate here that it will be fine at C++ if you give it enough information about what you want to happen. But yeah, does that make sense?
Sure. I want to return to
I haven't forgot about you.
the argument that like in an enterprise code base, there's nothing that's that feels safe to use an LLM on. And like, so I work on trading systems, right, which is arguably like one of the highest stakes things you could be working on, right? Like I can pretty directly light money on fire.
In other domains, people do not.
We've established lighting money on fire is just as bad.
Whistle also lights money on fire, though.
I have use cases regularly where it's like, man, it would be really nice to have a one-off tool to do this analysis. It could be as simple as like you have a bug, you have to sort through a ton of data. Like maybe you could like rep through those logs and find it yourself, but you'd probably be more effective if you had a one-off Python script that would systematically analyze those logs.
It's like peripheral tools.
Yeah, like if you're not cranking out a ton of those with these tools already, like think about where you, like any time where you're like, man, I really wish I had X, but instead I'm just gonna do it like slowly the manual way. Like just point an LLM at it, and you'll probably, you know, like for your like core critical stuff, like probably be pretty hands-on with it. But for the edges, you know, like analyzing Git history, right, where it's like, hey, I found this bug, I don't know when it came in or why it came in. Go through my Git history, figure out what's wrong. I use it to write Git bisect scripts all the time, like probably one a day. Log analysis, I like have not gone through logs manually in a long time.
How many bugs do you have to bisect?
This is a peculiarity of my workflow. As much as that, it's usually bisecting on local branches.
Something else I want to.
Well, the question is really like, where did this test start failing, so that I can put the fix back into the correct.
You shouldn't have committed it.
You should.
Well, this is what I'm saying, where it's on a local branch, right? I have a local branch with 5 commits, and I'm like, crap, I found one more bug that stuck in when I did this rebase.
I want to get to him.
When you like, but when you have the ability to like trivially, hey, write this bisect script, just like go do it, and then you can like go do something else while it's finding it.
Yeah.
Like, you know, like sure, why not? Like normally it would be like, okay, I'm just gonna leave things in a crappy state for my future self, my coworkers who might come back through here. But I'm like, no, I can easily like just find the commit that this was introduced in on my local branch. No overhead to me, right? Like just go do something else. Like why not? It's free. Like
There's an asterisk next to free. Yeah. Thank you, investors.
Related to the topic of hallucination and what's in your context window earlier, an observation that I've made is that even with the better models, a surefire way to get it to hallucinate, usually repeatedly, is by giving it incorrect or even just conflicting information about what you want. So it is very important. I think that hallucination is less and less of a problem, but you still can. It still does happen, and sometimes if you're getting like consistent weirdness, you should check and make sure you don't have 2 rules that are telling it not to do the thing you're asking it to do or something.
Or
Yep.
your documentation is outdated.
Yeah, and you can handle all of these things by basically telling it when you're prompting it. Say, if you find conflicting information, bring it to me. If you find something that's unclear, bring it to me. And you can use it to basically bubble up those problems in your code base to the surface and go address them. Yes.
So my question is about, like, I guess, the influence of code ownership here. So are we yet far along enough here that to say, like, do you have experience of like shipping code that AI wrote and finding a bug in it a year later and having to fix that bug?
Yes.
And how did that go?
So again, like this has to do with, in my mind, that red yellow green space. Anything that is going to cause an issue that we cannot live with, we try very hard not to ship any bug like that. Anything that is
Not to ship bugs, but
sure,
you know, we
but
ship
but
code, which means shipping bugs.
sure. I guess the bugs that I can think of were either like something that lived for that long. I can't think of one that wasn't something like a UI defect.
Okay.
Right? It
So
wrote
nothing like a race condition.
no.
Because those are the ones that live long.
So concurrency is concurrency is an area. Huh?
But then it solved the memory leak later.
That's true. Memory leaks, you just add more RAM to the VM. It's fine.
Security issues live a long time.
Yeah, I want to say concurrency is very in the red for me. I would not throw my LLM at a concurrency issue and like ever ship the code without reading it very thoroughly and saying to myself, this is as good or better than I would do.
All of your CI dashboards run with thread sanitizer anyhow, right?
Right. I mean, I think that proper tooling is another thing that helps AIs tremendously. But again, concurrency is just one of those areas that I'd consider in the red zone.
Maybe the real problem there is design, right? Where like, why did you design a system where concurrency was like potentially an issue?
All I do. I live in the world of interrupts, like the sea of interrupts.
You need to build like, this is where like building a pit of success becomes, like if you build a pit of failure, like a junior engineer will fail just as much as an LLM will fail. If you build a pit of success, right, if you like strongly type all your interfaces, you know, like make sure that your lifetime models all make sense, this sort of thing. It's a lot harder for these sorts of things to like sneak in. And where you do find them, you need to ask the question, like what was wrong with the design that allowed this to exist undetected in the first place? Not, oh, let me go patch
Some of
the
that
code.
they can do. It's horses for courses, right? It's
Yes.
like Tony was saying, firmware is one of these cases that most people don't think about. Like normal C++ desktop programming, sure you might use some threads, you might use some of that. Firmware, you've got hardware that's fundamentally parallel, right? The hardware's doing stuff while you're running and you have no idea, and an interrupt fires whenever, in between instructions, sort of thing.
Have you explained that to it?
Ben has the wrong person.
I really think that
I mean, I haven't explained it to it because a lot of it is like outside C++ as well.
Yeah.
Right?
I think that firmware is going to be a pretty hard domain to get a lot of use out of agentic coding. What's up?
The two comments of it vomits an enterprise-sized software, and if you give it two different directions that are wrong, those things kind of go together, I think,
because it's the inherent truth of enterprise software.
I have a point. You can ask the agent to evaluate whether or not your documentation is correct with the code.
Yeah.
And that is not writing enterprise code that you have to be concerned about. It's validating documentation. And they're like pretty darn good at that kind of thing.
I think that's one thing about like you're almost creating a DSL for your junior engineers and also these agents. Like you're giving them less room to make an error, I guess.
Yeah.
And also, in such a big code base, I don't know if it compares to SketchUp or anything.
SketchUp is not tiny, right?
Tiny, I guess, compared to.
Not tiny, not tiny. It's not tiny. It's got. I was gonna say it has to be. 'Cause it's been around for
I mean, for 20 years, there are so conflicting information in it. Even adding, subtracting vectors, somehow we have still finding bugs because 10 years ago somebody did fix a bug totally unrelated way or wrong way because we didn't do code reviews by then or something. So then LLM looks at it just like a normal engineer, even someone like me, 20 years of C++.
Look, I have I see there's more questions. I have a couple more things I want to show you guys before we're done, and we're getting close to the 8 p.m. point where I want to really transition to talking and not presenting. So there's a couple of things that we. I want beer at 8 p.m. There's a couple of things that we haven't really talked about, right? So I want to show you what a skill looks like. Okay, here's a skill. I wonder if I can actually pull up a run, or we could. Yeah. Thank you. Thank you. So here's a skill. It's just the best practices doc that I took, and it's got a bit of header on it that explains to the harness when to use the skill. And I actually ran this. I think I deleted the run because I was thinking to myself, let's do it. Let's run one of these. I don't think we've got enough time to sit here and plan with it and actually get a good output. So what will happen if you have a skill is you will run something like a plan, and that plan is going to say, write some classes, write a main file, write some tests files, write some CMake. And it's going to use this skill to write each of those classes. It's going to use this skill to write the tests, and then it's going to use this CMake skill to write the CMake itself. And this is great because we basically pull all of that context around writing C++ and CMake into sections when we actually need the LLM to know about those things. We can actually go a step further. I want to show you one more thing. Where is VS Code? Oh no. Can I get to this way still? I hope so. I don't want to have to redo it.
I just realized Claude's icon is the I just made AI from the Marvel.
Great.
Tony accidentally makes AI. That's what it looks like, right?
Okay, so we can also, some front ends give you this idea of subagents, okay? So I'm going to hide, what is going on here? I guess I have to close this because it's its own tab. Yeah. So in this attempt, what I did was I wrote agents. I wrote an agent for CMake. This is not an agentic workflow. This is actually telling Claude, which has this feature, to go call a different agent altogether to write CMake tasks and to do the same thing for C++.
How are you telling it to do a different agent?
I just tell it in the plan. Here, we'll go up.
Sorry.
No, this is.
Just basically restart your context somewhere else.
It's actually like
What helps your context live?
the parent agent feeds the context to all the other agents. So let's go to an agent call. This is like too big for me to read. There we go. Okay. Okay, so here was me making my plan. I made my plan with it. Great. It made a test plan. This all looked great. And then I told it, I did. I'm trying to figure out where I did that. I basically said, go do this and use subagents for all of the tasks. And here you can see it did it. And this is the context it gave this agent. It said, you go do this. You already have all the context for writing a CMake. And here's the instructions I've got for you about doing this piece of the plan. And then it did the same thing for writing a memory class, right? And all of the context about how I want the C++ actually written is in that agent definition. And all the instructions that it was given on what we're actually writing was done right here. And so this is about as state of the art, I think, as you can get right now. I'm sure that experts in this field would disagree with me. I'm not using beads, and I'm not using all kinds of memory upgrades. Beads is this thing that turns your your AI to dos into like a database. And we can go look at it.
That was an Arrested Development reference. No one at all got it.
This right here, right? I'm not. Now I got it. Yeah, just the way you said it the first time, it wasn't good enough. I'm losing. There's too much laughing going on. Yeah, I think it's all right here, right? Is this? Yeah. Yeah. Where's my Claude code?
That's what the beer is for, right? Beer clears your context.
Beer clears. Beer is human context clear. How do I get to Claude code? Yeah, past conversations. Anyway, yeah. So, but I think that for 99% of use cases, having a subagent which has the context for the specific task you're wanting to do, maybe you could even have one that does something like concurrency, or one that understands specific aspects of your hardware. having an agent that understands the goal that you're trying to achieve here, something like we need to actually test this bug. And then it calling subagents to write the test is about as good of context management as you can ask for. And so this is about as good as I think you're going to get in terms of getting good accuracy out of these that doesn't involve actually explaining the problem well. That's my talk.
Thank you.
Yep.
You're just like, I'm done.
Chris.
So first of all, where are you getting the actual metrics for context usage, and then how do you interpret that to inform whether or not you think that's too much?
It is a look and feel thing to tell what's too much. Claude Code will, nearly all of them, I haven't figured it out with anti-gravity, that's why I'm not using it, but Claude Code will literally let you just ask it for the context and it'll tell you. Here's what I got.
Is that metadata, or is that a prompt response?
I am not quite sure how that works.
Okay. Anybody know if there's a cursor equivalent?
Yes, cursor will do the same thing. Cursor gives you a little icon that you hover over. There's no command, but there's a little, yeah.
Strongly recommend putting it on your status line or something so that it's just always.
Yeah, I do.
You said 50%. Is that like a kind of good starting point for feeling?
That is a look and feel thing for me, who is usually doing something probably less hard than you, Chris Thrasher, are doing. So I don't, huh? So I don't know. You need to figure it out for your own use cases most of the time and for the model that you're using. I talk to some people at work who feel like Claude 4.6 never gets to a point where it gives them something bad. Here he is. I am with John, where as soon as it gets past 40 or 50%, I say to myself, I have done something wrong. That we should not have gotten this far with this many tokens to have read. New prompt. Let's make the problem smaller. At 100%.
Well, it has Claude Code. It varies by harness. Claude Code has a setting for it where you can tell it, but yeah, it's very high.
I think you've had your hand up for a while, actually.
Yeah, I've talked a lot.
Well, so one of the reasons why sub-agents helps keep your context in check so well is because, like, say you want to have it, like your prompt to the agent is go explore the code base and come back with something and then make the plan. It can spawn a sub-agent to go and explore the code base.
Yes.
So instead of the context for your agent being everything that it has explored and read, and then trying to make the plan with all of that context in mind, the agent comes back to it with a summary of what it explored and found out. So the context isn't all of the things that it read, it's a summary of the relevant information that sub-agent then comes back to the main agent with.
Yeah, these are all just context management tools.
Can you go back to the slide that shows like the 3 layers of like, here's the harness, here's the agent, here's the agentic workflow.
Yeah.
You were talking about like state of the art, and then I forgot there's another comment that like reminded me of it, but there's like a 4th layer that's starting to pop up. Is this where I found like a nice little niche for myself to work on that doesn't really like this stuff, but I have to like my company built an agent is like an orchestration layer where I think Cursor does it where they do sub-agents, but you can do like parallel sub-agents, and they each like spin up their own Git work tree, so they can work on a code base in parallel without stepping on each other.
Yeah,
to like orchestrate all that together, and then also starting to sandbox them, putting them all in their own little like VMs instead of like locally on your machine and doing all stuff like that.
Yeah.
The little infrastructure layers.
The workflow layer the workflow that I showed you with those agents, it did all of that in parallel.
With the Git work trees and everything.
It did not do Git work trees. So that's like an additional feature on, and I can totally see us getting to a point where we have to talk about an orchestration layer as a definition here. Yeah. Brian.
So a terminology question. We're talking about like the context. Does each agent have its own context? So if you've got 2 different sets of context,
Yes.
does that mean you've got 2 agents? Is that the right terminology to use?
Yes, it's literally I mean, the better way to think about this is each time you make an API call, you give it context. And your harness is slowly collecting these things. So every time it makes a subsequent call, it puts in there, here's the rest of the conversation. Here's the things that we did already. And so it's building up this big block of text with each API call. That's really your context, but the way that we think about it is yes, like each sub-agent, the harness is collecting a list of, yes.
Sub-agent is associated with its own mutated context.
Yes, 100%. Lenny.
Well, to his point about using sub-agents, you use the sub-agents to do things like explore while you're in plan mode. And then the plan mode is going to generate you a plan. And then you can clear your context and feed it the plan.
You can.
And that continually, so as you're doing that, you're like continually clearing your context and keeping your context window small. So I almost never run out of context window because I'm always clearing it.
Yeah.
That's my standard workflow is to use sub-agents, create a plan, clear the context, feed it the plan, and repeat.
I propose to you that working on a bigger problem, like where we have more tokens, you will hit a point where you will see an even better situation by using the sub-agents to make the plan, clearing your context, refeeding the plan, and farming all of the to-dos out to sub-agents, which is what that workflow did. And I would only do that for a problem where the definition of it requires a lot of pieces of working code to be understood. I also never really need to do that. I just clear my context or summarize, ask it to put, what I usually do is I have a .md file where I say, go summarize everything we know about this particular problem in here, and I open a new window and I feed it in there and I say, we're still working on this. Yes?
To make that even better, if you have a large task, like the plan is really big with a lot of subtasks in it, what can make the code quality better is if you take it one step at a time, like you clear context and then say like, just execute the first part of this plan, and then you write unit tests based on that, and then you check it, and then you commit that, and then you review it, and then you go on to the next part.
Yes, but what if your code is such a mess that it does not compile after that first to-do is done? What then? That's kind of the situation that I generally imagine whenever I am dealing with a really large problem. The other thing that happens to me specifically at work is I have a lot of microservices. And in order to make a plan that we actually understand the pathway of a piece of traffic from where it comes in to where it leaves the system requires a lot of moving parts. Actually executing the code is not a problem, but getting to the point where that plan is actually correct is hard. Yeah.
So in order to instruct it to call out to a sub-agent, you literally just put that in your instructions?
Yeah, I need to find it in here. That's all I did. I literally said, I want you, it is just a tool.
Working with that as a sub-agent, just because you said
What I specifically said in that one was, so it made a plan and it said, I'm going to write tests for these cases. I'm going to write this class, this class, this class, this class, and then I'm going to write my CMake. And I said, do each one of those to-dos with the sub-agent. And then it did them all in parallel. And it was a lot of RAM.
But do you have to explicitly invoke an agent? It's not like the tools where the harness will look through the list and say, oh, we have this agent's folder, let me go look at them and see which one to use.
At this specific moment, with Claude Code, with as much as I know about it, I do. I don't know if there's a mechanism that I don't know about in there. I cannot tell you how many times I opened a harness while making this talk and told it to do a thing, and it did something very different than the last time I told it to do a thing. I will be completely unsurprised if I open Claude Code tomorrow and tell it to do something and it spawns sub-agents to do it all without me saying anything. completely unsurprised. I will also not be surprised when the day comes where when I ask it to make a plan, it pulls the plan up and opens a GUI and tells me, draw out the subagents that you want to happen here. Like, tell me how you want this workflow to go. I will be unsurprised by anything like that at this point because the rate of progress is just monumental and they're changing the way that we interact with these things constantly. Is it time for Burns?
Yeah.
Great. Thanks, everybody.